Hello, everybody. Welcome to one more exciting session in the series AWS Bootcamp. In this particular session, we'll basically discuss about what is a server, what are the uses of server, and we'll understand what is a virtual machine and difference between physical server and virtual machine. And we'll understand the service on AWS which is called as Amazon EC2, which is a virtual machines that you can create on AWS. And we'll understand different EC2 instance type. We'll look into security groups. We'll understand some of the ports, and we'll do a demonstration of how to create a Windows EC2 instance and a Ubuntu EC2 instance. That is what we're going to discuss in this particular chapter. First, let's start with what is a server. Now, a server is a high power computer. It is built to store and process and manage data, devices, and systems. Now, if you want to host a website, you need a server. If you want to process data, you need a server. Now, you can consider servers are the vehicles for hosting and processing intensive workloads that go beyond the capabilities of traditional computer. Now, let's say we have our laptop or desktop. There are some capabilities which are not there, which server has because the servers has a server operating system. Now there are different operating systems that the servers has. One can be a Linux operating system, a Unix, Ubuntu, Windows, CentOS. There can be different types of server operating system. And a server to function as a server, a device must be configured to listen to the request from the clients on a network connection. This is one of the mandatory component. If I have to, if let's say if a computer has to work as a server, first of all that has to be configured to listen to the request from the clients over a network. That is what a server is. Now, what is a virtual machine? Now we can consider a virtual machine is something like now if we say this as a physical server. Now there are different components in a physical server. There is a server hardware, there is a host OS, there is a hypervisor, and there are multiple applications on the hypervisor. So this one we can call it as a virtual machine. Okay. Now each virtual machine stores storage and it is hosted on a physical server. Okay. Now, one physical server can have multiple virtual machines. Now, VMs are often thought of as a virtual computers, or you can refer them as software defined computers within a physical service. So, all these virtual machines are there within a physical server. They are existing as a code. Now, what is the difference between a physical server and a virtual server? Now, physical servers are powerful computers, usually stored in a data center for business use cases. They that run operating systems and applications of their internal hardware resources. Now, a virtual server is a software-based environment that emulates the process of an actual computer. Now, if you look into the difference of a physical server and a virtual server, you can see in a physical server, okay, there are multiple layers. What is the layer? The first layer is called as a hardware layer, which has CPU, memory, and storage. And top of that, there's an operating system, and database is configured on top of an operating system, and your application is hosted so that your application can store the data in a database. And if it wants to do any processing with the help of operating system, the processing can happen. But if you look at a virtual machine, on the other hand, a virtual machine is also, you have the same components: CPU, memory, disk, operating system, and application, but it is there on top of a hypervisor. It is a special software, okay, kind of special operating system like an EXXI or a Citrix Zen. If you look into AWS, the hypervisor name is called as a Netro. Underlining that there is actual physical hardware. Now, both the virtual machines share the hardware from this physical server, either disk, memory, or CPU. Those are shared between the multiple virtual machines, share the hardware from a physical server. Now that is what a difference between a physical server and a virtual machine. Now AWS has a service called as Amazon EC2 Instance. Now what is this EC2 instance? Now on AWS, EC2 instance is referred as infrastructure as a service. In the introduction, we have looked into multiple services that cloud offers. One is infrastructure as a service, platform as a service, software as a service, right? Now, EC2 is referred as infrastructure as a service. Now, EC2 provides scalable computing capacity on AWS Web Services. That means you can consider EC2 as a resizable virtual machine. That means if you want to increase the capacity, you can increase. So when I say increase the capacity, it could be a storage capacity, a RAM capacity, or a CPU capacity. You can increase or decrease. Now, users can use AWS EC2 to launch any virtual machines as they need, configure security, networking, and manage storage. So, with the AWS gives you a console. So, with the help of console, we can create any number of servers, or in AWS terminology, you can call it as EC2 instance. We can create any number of EC2 instance. Not only creating, we can also secure them by configuring security, and we can also configure networking, and we can manage the storage with the help of EC2s. Okay, now let's dig little dive deep into EC2 instance. Now EC2 instance is called as elastic compute cloud. Okay, now you can simply say EC2 is like renting virtual machines from AWS cloud. And couple of more capabilities of EC2, like you can store data on virtual drives. The virtual drives on AWS is called as EBS, Elastic Block Store, and we can configure Elastic Load Balancer, and distribute the traffic to multiple EC2 instances with the help of Elastic Load Balancer. In the subsequent chapters, we'll see about Elastic Load Balancer. So EC2 is capable of all these things. Now, there are a couple of advantages why we have to use an EC2 instance than a traditional on-premises server. The first and foremost is it is very cost effective, because if you have to purchase a physical server, you need to pay all the money upfront. That means the capital investment is there. But for an EC2 instance, there are multiple plans that AWS offers, like on demand, reserved instance, or spot instance. So whatever it is, you can choose a flexible plan to pay upfront or to pay once you use the service, or you can also go for a partial payment. So based on what type of payment method that you use, AWS offers you discounts up to 70%, right? That is something very, very absolutely good, and you can pay once you use the service. There is absolutely no capital investment as well. Okay, and it is scalable. If you purchase an EC2 instance today with two vCPUs, tomorrow if you want to increase to four vCPUs, it is absolutely possible. And today if you purchase an EC2 instance with 100 GB of storage and you want to scale it to 200 GB, and it is absolutely possible. Or else if you want to decrease to 500 GB, it is possible. So that is basically called as elastic. Okay, and it is quite secure and reliable. These are some of the features of or benefits of EC2 instance. And now when you purchase an EC2 instance from AWS, what are the things that you have to keep in mind? First of all, you have to understand the EC2 instance that you're going to create, what operating system it should have. Okay, we need to based on the operating system that we select, once an EC2 instance is created, that voice would be there in that. And what should be the compute power, what should be the RAM, that means how many CPUs, what should be the memory, what should be the storage, how the security has to be configured, what are the bootstrap commands that you can put in. So all this is part of EC2 configuration. So when you create or let's say when you go on e-commerce website Amazon in, when you purchase a laptop, you mention the configuration, right? How many CPUs, what should be the SSD, all this configuration. So when you purchase an EC2 instance from AWS, you have to make sure that you have to specify the configuration. But don't worry, AWS gives you a lot of the menu is really big. You can choose one that fits your configuration or suits your requirement. Now, this is somehow it looks like this. So if you want to choose a uh, operating system with Windows or operating system with Linux or Ubuntu, Unix. Okay, you can choose one of the operating system. Trust me, there is every operating system in the menu, so you can get one operating system that you're looking for. It has all the flavors of Unix and Windows, so you can choose one. And now, see, every customer needs are not same. So everybody, one type of EC2 instance will not be able to satisfy all the customers, right? So there are different types of EC2 instance that can cater the needs of all the customers. So because there are different types, there are different naming conventions. Let's say, for example, there is something called as T2 medium, T2 large, M5 X2 large. So what does this mean? T, the first letter, stands for instance class. And then it stands for the generation, whether it is first generation, second generation, third, fourth. So AWS keeps on improving them over time. So if you see more than one, that means that you can consider that as a next generation. And 2x large or medium or micro, macro. So that stands for the size of the instance within that particular class. Now in T2 there can be a large. In T2 there can be X 2x large. In T2 there can be micro or mini. So basically that determines the size within that particular instance class. So there are different types of instances that we can choose which will fit our requirement. So broadly, this EC2 instance types are classified into a general purpose EC2 instance, compute optimized EC2 instance, memory optimized, and storage optimized. Let us look into these different types of instances. Now, a general purpose instance, it is great for diversity of workloads such as web servers or code repositories. If you want to host any web applications, this is good. So now, what does this general purpose provides? High in memory, high in compute, or what resources it provides? So basically, general purpose instance provides a balance of compute, memory, and networking resources to make sure that your application performs better. Now, let's say there is some application you want, it is very compute intense. It requires more compute resource. Then for that, maybe general purpose is not a better choice. Then you can choose something called as compute optimized instance. So now this compute optimized instance are ideal for compute bound applications that benefit from high performance processors. The processors are the number of processors are high, so the compute would be faster. Now ideally this you can use for batch processing workloads or for high performance web servers, or once you want a high performance computing for your machine learning models or for some gaming servers, you can use compute optimized instance. So a compute optimized instance, if you see, it will start with C, and C5, C6, C7, those are generations, right? So it can start with C. That is what a compute optimized instance is for you. Now let's say I have a use case that if my compute is okay but I want to store huge amount of data, then maybe compute optimized is not a good option for you. Okay, if you want to have a good memory storage, okay, then memory optimized is better for you. Memory optimized instance are to deliver very fast performance for workloads that process large data sets in the memory. Like for example, if you want to create a Spark cluster, or if you want to run your Spark programs, your Spark program basically runs in a memory, right? So in that case, you might require a memory optimized instance, which is good for performance in memory, like in memory databases. If you want to create, if you want to process unstructured data, right, then memory optimized instance. So the memory size, that means the RAM size, would be huge. Now let's say you're not worried about processing or performance. All that you need is you want to store huge amounts of data. Then we have another type of storage which is called as another type of instance which is called as storage optimized. Storage optimized instances are designed for workloads that requires high sequential read and write access to very large data sets on local storage. It is basically used for OLTP operations, that is basically for analytical processing. You can store your relational or NoSQL database. You can also use it for data warehousing applications or distributed file systems. Right. Those are some of the use cases for storage optimized. Now, if you look into the EC2 instance types, there is large in one type only. There are multiple sizes as well. If you see, there we have large, X large, 2X large. The CPU power is changing, the memory is changing, right? That is about instances. Let me show you guys on the console different types of instances that we have. You see, this is the AWS console, and I'm in the instance types. You see, there are multiple instances. There is T1 micro, T2 nano, which comes with one vCPUs. Okay, there is CX large. You see, there are about 559 types of instances. And now let's say if it is T1 macro, it comes with one CPU and the architecture is this. Okay, you get this memory and you don't get any storage. The network performance is low. And the charge, basically, if it is a Linux, it is zero point 0.0 USD per hour. And same thing for the Windows. Now let's say, let us go for a high-end mission and see what is the cost. Let's say M4 4x large, there are 16 vCPUs and 16 GB memory. The performance is very high and the cost is zero point 0.8 USD per hour. If it is Linux, and if it is Windows, because there is a license costing as well for the operating system, the cost is 1.536 USD per hour. Okay, so this is on demand pricing. So we'll discuss in a bit what is on demanding. We also have something called as a reserved and spot instance, or we have something called a savings plan. We'll look into that later. So these are different. You see, there are 559 types of instances that you can choose from. That is apt. You can choose the apt configuration for your application that you want to host, so that you don't waste any money. Okay, that is about different types of instances that we have. And next, let us discuss about something called as security group. Now, one of security groups is one of the component that you have to create when you're creating a EC2 instances. Now, what is a security group? A security groups, you can say it simply acts as a firewall on EC2 instance. They will specify which traffic has to come inside, which traffic has to go outside. Okay, that is called as inbound network and outbound network. So from outside to the instance, from instance to the outside. Now so basically in a security group, we have to mention, hey, this port you can open that. Let's say RDP port. If you open RDP port, that means the instance is capable of allowing RDP traffic. If you open SSH port, we can open a database port. All right, so based on what kind of port that we open, the traffic would be allowed from that particular port. So we can access the ports and authorized IP ranges. We can also say, hey, now let's say this set of servers can access this virtual machine. We can give an IP address range. So the IP address range can be defined in IPv4 and IPv6. So basically, security group is to control the inbound and outbound traffic. That is what a security group will do. Just to visualize, now from the net, there's a incoming traffic that is coming in, outgoing traffic that is coming in. First of all, the traffic has to go through the security group. Okay, if you have to reach to EC2 instance, the traffic has to either it has to reach to the security group, either incoming or outgoing. That is what is the use of a security group. Now, if you look into that security group, there are some sample. I told you that there is port numbers, right? We can open a port like SSH, which is 22. We can open a HTTP port at port 80, or we can open all the ports, and we can say, hey, I'm opening port 80. Now, what all IP address I have to allow? If I'm giving 0.0.0.0/0, this is the CIDR range. That means I'm allowing every IP address. Now the first one you see 2030.113.1. That means I'm only allowing set of IP addresses to access that particular instance. Okay, now you can also see there's an EC2 instance. Its EC2 instance IP address is 12.34.56.97. I have opened port 22. So this computer can access this particular instance. Okay. Now other ports, if you have not defined anything, we will not be able to add it. And in the security group, there is we have added any. That means this particular port can communicate because this is there on any port. So basically we can define which has to access and which does not has to access. Now a couple of more things about security groups. Security groups can be attached to multiple instances. So it is not like one instance, one security group. We can create one security group and assign that security group to multiple instances. And security groups are logged to a region. It is not a global resource. If you're creating on US East one security group, that is only in US East 1. Okay. Now a security group does live outside the EC2. If traffic is blocked to the EC2 instance, won't see it. So basically a security group is not there in EC2, it is outside that. So then only it can manage the traffic. It is good to maintain one separate security group for SSH access. So for RDP one security group, for SSH one security group, it depends on what kind of ports that you want to open. Now, security groups, if your application is not accessible, then it's security group issue. Most of the times, you'll get issues like, hey, my security group is not accessible. Or sorry, my instance is not accessible. That could be an issue with the security group. And your application gives a connection refused error, then also it's an issue with the security group. If all inbound traffic is blocked by default, so when a security group is created, by default all the inbound is blocked, all outbound traffic is authorized by default. So if we have to allow any inbound traffic, you have to basically add that rules to the security group. So a couple of ports that we can add to the security group: an SSH for a secure shell, an FTP for a file transfer protocol, and SFTP for a secure file transfer protocol, HTTP at port 80, HTTPS at port 443, RDP at port 3389. These are some of the classic ports uh, for us to add to the security. And now let us look into a small demonstration how to create a EC2 instance with Windows operating system, and we'll also see how to create a EC2 instance with Ubuntu operating system. These are the two lab exercises that we will do with this in this chapter. Let me flip to my AWS console. All right, this is my AWS console. Now let me, so if you click here, you can see all the applications, all the services that you can access on AWS. Now want to use a service called as EC2. Select option EC2. Okay, now I'm there in a region called as North Virginia. So if you want to create a EC2 instance in London, select option London. Okay, so that is how you can choose in which region you can create an EC2 instance. Now I want to create an EC2 instance. You see there's an option called as instances. You can also click here, or else you can see there's an option called as launch instance. You can also click there. You can also click on launch instance here, and there will be an option which says launch instance. Let me select this option, launch instance. I will name the server name as demo win. That means we are going to create a Windows operating system, right? So we have another chapter for AMIs, which is called as Amazon Mission Image. But let me just give a brief. Amazon Mission Image will contain all the software that you want on the server to be. Now I want to have a Windows operating system or plus some software. Then select option Windows here. Okay, I want Windows. So now here it is showing different types of Windows OS. It has Windows 2022, Windows 2019, core base, Windows 2092 with SQL Server, Windows 2016 with SQL Server. There are a lot of options there. You choose one which suits your requirement. Okay, choose any free tier eligible one. Okay, and we have selected our AMI, and then you see the instance type. We discussed that there are different types of instance, right? We can choose that, and you'll see all the types of instance. We saw that there are about 559 types of instances, right? If you want to compare any instance, whether this how much performance that is going to give you and all, you can select this option, compare instance. Okay, here you'll get all the types of instances and how many CPUs, what is the architecture, all the information you'll get here. I want to select a T2 nano instance, select instance type. Okay, I got the instance here. And for security, AWS gives an option called as key pair. So what is a key pair? So now once you create a key pair, okay, let me select option, create a new key pair. So I'm saying key pair name is win login, and it should be a PEM file for Windows. Okay, create a key pair. Now, as soon as we do that, there is one key that is downloaded. That is my private key. And AWS also stores one key that is a public key. So, these two, public and private, is one pair. So, Win login PEM is my private key, and AWS stores my public key. So, what happens whenever I want to have a password? If I give my key, AWS with the key that is storing, it will decrypt a password. Okay, that is the use of a key pair for a for security. Okay, AWS offers this key pair. And network, I will leave the networks as default as of now, because we have another chapter for network. And if you want to host a website on this, you have to open a HTTP. If it is secure, you have to open a HTTPS port. Now, but we have, I told you about security groups, right? So if you want to create a new security group, you can select this option. If you want to select the security group which is already existing, we can select one. But let me create a new one as of now. Create a new security group. Okay, the security group name will be called as Launch Wizard 5, and these are the ports that I'm adding to that security group. Okay, and this is the storage. We'll discuss about the storage when we are adding additional storage. And then launch instance. Now this will launch a Windows instance for us. View all instances. You see the demo Windows instance state is pending. Let us click here. The instance state is pending. It might take about a moment too. It is still in pending state. It may take about another moment for the instance to be created. Now you see the instance state is running. Okay, that means this instance is created successfully. Now if you look here, there are a couple of things. Okay, one is you can see the ID of the instance. So every instance that we create, it will get one public IP address, one private IP address. Now we'll discuss in the chapter VPC what are these public IP address and why do we need private IP address. It will also get one DNS name. You can either choose a public DNS name or a public IP address to log into the instance. Okay, and you get the name of the server and an IP address which is automatically assigned. Okay, and you'll get the AMI ID that we have chosen. What is the OS? Okay, what is the AMI name? What is the AMI location? You get all the metadata of this particular EC2 that we have created. And if you go into security, you will see what is the security group that we have selected when you're creating it. So this is the security group. Now launch wizard 5. Let's go and see what are the ports which is there in that. Okay. Now if you see inbound rules, there is a HTTP, RDP, HTTPS. Because it is Windows, we need an RDP port. So the RDP port is a 3389. So these three, we have added these three ports. That means communication from these three ports is allowed. Okay. That is about security. And let us see a couple of more options which are there. Okay. If you look into the networking, you'll come to know about the networking details. In the storage, you'll come to know how many volumes are attached. Okay, and Status check, we'll come to know what is the status of this particular instance. Monitoring, you can have monitoring configured here. We can also have detailed monitoring. In the CloudWatch, we'll discuss about this monitoring and the tags. Okay, these are the different options that we can see. Now, let us say I want to connect to this particular instance. How do we connect to the instance? You see, there's an so we have to connect basically with public IP address. Okay, select RDP on your laptop, so you'll get a remote desktop connection, and you can put the IP address here and select option connect. Now the default username would be administrator. Okay. Now what is the password? To get the password, you need to select this option connect, select option RDP client, and you see there's an option called as get password. Select option get password. You see it is asking upload the private file. Select option upload private file. Go to downloads. The PEM file that we have downloaded, we have to give it there. Okay, winlogin PEM is the file name. Open and then decrypt password. See, now I got the password to connect to this. Select this password. Go to the instance here. I have given the username and the password. Click on OK. Click on yes. It will take a moment to connect. Now you see we are connected to this instance. This is a Windows EC2 instance that we created on AWS. We are able to connect. All right. Now let us go ahead and create a Ubuntu EC2 instance and then connect. So for that, let me go here, select option launch instance. Okay, select, give the name as Ubuntu server, and here select the image Ubuntu. Okay, in the quick start, select the image Ubuntu. We'll discuss about AMIs in the next chapter, but select option Ubuntu here, and you can select different Ubuntu versions, different types of Ubuntu OS. You can choose any one of them which suits your requirement. And the instance type, I'm choosing it as macro, and create a new pair. I'll say Ubuntu 1. So now here for Windows we have chosen PEM, okay, which you have to use with OpenSSH. But for PuTTY you have to select something called as PPK. Okay, for Unix based operating systems we have to select PPK and create a key pair. So as usual, a PPK file is downloaded, which is a private key. Now, if you want to add this ports, you can add, or else you can just leave as it is. Now, if you see, by default, there's a SSH port which is added. Previously, in the Windows, by default, there's a RDP port which is selected because Unix work at a SSH port. Okay, rest all, I leave it for defaults as of now and select option launch instance. Okay, instance is successfully launched. You see, this is the Ubuntu server. Select this option. You see, there's a public IP address which is generated. Instance state, it is pending. Let us wait for a moment. Okay, now the instance is in running state. Now let us connect to this instance. Copy the pub IP address. And to connect this instance, we have to use a tool called as PuTTY. Okay, if you don't have this tool, go to putty.org and download the PuTTY utility tool there. Okay, now I'm opening PuTTY and connect the IP address here. Okay, in the name of host name, put the IP address. Now we have to give the password, right? The PPK file. Now you see on the left, there's an option called as SSH. Expand this option. And here there's an option called as authentication. Select open. Okay, now accept this and it will ask for the username. The default username for Ubuntu is Ubuntu. And then click enter. Think we have not given the PPK file. One moment. Give the IP address. Go to SSH, go to authentication and select option browse. Here you have to give the PPK file that you have downloaded. The PPK file name is Ubuntu 1 PPK. Select option, open, open, and then give the username, enter. You see, you are able to connect to the Ubuntu instance. Okay, that is how you can log in to Ubuntu instance and Windows instance. All right, we'll see a couple of more options in the next chapter. Okay, to summarize this, we basically looked into what is a virtual machine, what is an EC2 instance. We understood difference between physical and virtual servers. We understood about security groups, and we also understood couple of classic ports. Now we also did a demonstration of creating a EC2 Windows server, EC2 Ubuntu. I strongly recommend you guys to do the hands-on exercises so that it will be easy for you to understand the further chapters. You guys have a good time. Take care.